welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family and my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, and Almighty my God, my friends, followers, my dear students and subscribers. And today's topic of interest is the objective type questions in engineering mechanics. As we said, a part 5. All the part 4s, part 1, 2, 3, 4 are will be given in the description box for your reference so that whenever you start a video, please see from 1 to the last. Then only you get a complete idea about the objective type questions in engineering mechanics. Today we are going to start with the question of the friction force, the maximum friction force which comes into play when a body just begin to slide over another surface. You have to remember this word, just begin to slide over. So that means it is called limiting friction. When it is stationary, it is called static friction. When it is moving, friction at moving object, it is called kinetic or dynamic friction. Since this is just begin to slide over, it is called as a limiting friction. So please understand the three types of the frictions. The next question is the minimum force required to slide a body of weight W on the rough horizontal plane is the rough horizontal plane is W tan theta. W tan theta is the minimum force required to slide a body of weight W on the rough horizontal plane. And the next very superb question, a motion of a particle round a fixed axis. So round a fixed axis which is called a circular motion. So it is not a rotary motion, it is a circular motion. Please understand about fixed, round a fixed axis, so it is called as a circular. So this is the fixed axis, say this is a particle, so it is take a round about the fixed axis, and this is called a circular. And next, a superb question. Please be clear about the levers. A pair of Smith tongs. You can note this. Smith tongs is an example of the lever of second order, whereas clinical tongs is the lever of first order. There is no lever of zeroth order. Please be clear that. So zeroth order is not at all there. Third order is there, but tongs will not comes under third order. So we have to make a clear about either it is a first order or second order. When it is a clinical tong, it is a first order, whereas Smith tongs it is a second order lever. So please be careful and clear. And next, moment of inertia of a circular section about its diameter. So about its diameter is pi by 4, pi by 64 d power 4, or pi d power 4 by 64, whatever may be. So this is the correct one, and pi d power 4 by 32 is the polar moment of inertia. Okay, so this is moment of inertia, and this one is polar moment of inertia. Okay, and next, very superb question, center of percussion. It is a very fantastic question. They are asking about the definition. The center of percussion is the point of application of resultant of all the forces tending to cause body to rotate about certain axis tending to about certain axis. So that point is called as the center of percussion. If you know that, if there is any railway station or a school, they usually put a rod for making a bell. Okay, so we hit we hit through the hammer in this direction, but what it will do means at some point it makes a round like this. So this point is called as a center of percussion. So about that point, the force which we are giving will make the body to rotate. So this is called center of percussion. Next, static friction. The static friction, in this question we can easily clearly understand about the static friction, which bears a constant ratio to the normal reaction between two forces. So it is a static body, so make a constant ratio. So you have to clear about this. It is a static friction. The body is in stable condition, so constant ratio of normal reaction between two forces will be there, and it is independence of area of contact between two surface. So friction, it does not depends on the area of contact. It is dependent on nature of surface area. So nature of surface area is very very important, and it is always act in the direction opposite to the body tend to move. Generally friction force will always act opposite to the motion of a body or a force. So that therefore all the above answers are correct. In order to clearly note the static friction or clear understanding about static friction, this question is very very interesting and important question. So none other question gives a clear understanding about a static friction. Please make a note of this and make this question as very very important for understanding the concept of static friction. And the next question is the ideal machines. The ideal machines, the mechanical advantage and the velocity ratio are equal. So equal velocity ratio and equal mechanical advantage. Therefore ideal machines will produce 100% efficiency. So these are all some terms we can easily understand. For an actual machines, mechanical advantage is less than velocity ratio. Therefore the efficiency is always less than the ideal machines. Ideal machines are theoretical machines, whereas actual machines working in nature. Next, the center of gravity of the triangle lies at a point of the center of gravity of the triangle. Please take this as a triangle. The center of gravity is here, which is nothing but the medians, the concurrence of the medians. The concurrence of the medians, they will join. The concurrence of the medians only they will join. Therefore option A is the correct answer. And next, a very superb question. They are asking about the kinetic energy of translation when a body of mass m attains a velocity of v from the rest in the time t. So a body is moving at certain velocity. What is then its kinetic energy? So kinetic energy, we know the formula of mv square. So here instead of they are putting 0.5, therefore 0.5 mv square. That's all simple about this. And next, the maximum efficiency of a lifting machine. When the efficiency of the lifting machine is mechanical advantage divided by velocity ratio, when we multiply when we when the this is the efficiency of the lifting machine, whereas the maximum efficiency in the case we are going to make the option D. Option D is the correct answer, where the product of mechanical advantage and velocity ratio inverse of these thing will give a maximum efficiency of the lifting machine. And next, a super question. In the equation of virtual work, the following force are neglected. So in terms of the virtual work, the reaction of any smooth surface with which the body is in contact it can be neglected. The reaction of the rough surface of the body which rolls on it without slipping, so that have to be neglected. And the reaction at the point or an axis in a fixed in a space around which a body constrains into turn, so that can be neglected. So all the forces can be neglected when the virtual force is happens. Okay, for understanding the virtual force, this question is an formula example of the understanding of virtual work. The next question is the velocity of a particle moving with simple harmonic motion at the dash at the mean position. So velocity of the particle moving in SHM, simple harmonic motion, at mean position it is 0. Sorry, at the mean position it is maximum. So at the mean position it is maximum and acceleration is been 0. So please be clear that at SHM, simple harmonic motion, velocity at mean positions velocity is maximum and acceleration will get 0. Next, a superb question. If a rain is falling in opposite direction of the movement of a pedestrian, he has to hold his umbrella less inclined when standing. Less inclined when standing is the correct answer. And next, a superb question. A resolved part of the resultant of two forces inclined at an angle theta in a given direction, which is equal to the algebraic sum of resolved part of the forces in the given direction, is the correct answer. These are all the resolution of forces. So once you come across these kinds of questions, you can easily understand what is meant by a force, a 2-force system, how it is working, and 3-force system, how it is working. Like that we can easily understand. And next, if a body suspended in a struck at the center of percussion, then the pressure on the die axis passing through the point of the suspension will be 0. So will be 0. If a suspended body struck at the center of percussion, so it is get struck at the center of percussion. If it is getting struck, the pressure on the die passing through the point of the suspension will get 0. That here you have to understand that we are arresting, so the same bell we are arresting at the center of percussion, so it is not hinged like this. In this condition, what all the force we are giving at this case, at here it is 0. At here it is 0. And next, the maximum angle of two forces when the resultant is maximum and minimum respectively is 0 and 180. In both this is 0 and this is 180. So the minimum and maximum will be lies between this. Okay, so if they are asking the angle of two forces when the resultant is maximum and minimum, so you can easily answer a 0 and 180. And next, a superb question. The velocity ratio of first system of pulley. We have a 3 system of pulleys, first, second and third system of pulleys. Here the pulleys, number of pulleys we are taken as an n. If it is an n square, it is a first order pulley. If it is n, it is a second order pulley. If it is 2 times of n, it is called third system of pulleys. Since they are asking first system of pulleys with 4 pulley, so 4 square we get a 16. If it is a second order pulley, and it will become 4. In the third order pulley, it will become an 8. A 20 is not an answer. So as I said earlier, it is a first system of pulley. Therefore, for the first system of pulley, so the velocity ratio is n square, therefore 4 square, which is equal to 16. So 16 is the correct answer. And next, a super question: when a person on a bicycle drives around a circle or curve, he has to learn dash to maintain equilibrium position. When it is a bicycle, he have to maintain an inward equilibrium. Then only they have to learn as an inward. Then only the uh, bicycle will maintain an equilibrium condition. Okay, whenever you ride a bike, take a turn. What you are going to do, if you are turning, if you are this is you, if you are turning in a curve, what you will do means you just make an angle towards the inward. So this is the curve center. You make an inward angle, then only your bike or bicycle will get we will put in an equilibrium condition. So this you have to understand. And next, the rate of doing work is known as power. And this is a very very important question. The impact between two lead spheres is approximately equal to an inelastic impact, and three forces acting in different planes can be represented by a triangle. Then these will be in, if three forces acting in a different planes, they are in non-equilibrium condition. So it will not be in equilibrium condition. So different planes, if it is a same plane, it will be in equilibrium position. If it is in a different plane, therefore you have to take non-equilibrium condition. So angle of triangle law says this. Okay, I hope you have enjoyed the part 5 of an objective questions. If you have any doubts, please let me know in the comment section, and I will put on another video for clarifying your doubts. So if you like my video, please do like, share and subscribe Mekiteki channel for motivating me and for making me put more videos about mechanical engineering. So thank you for the patient listening, and Jai Hind.